Okay, so this time around, we're actually going to explore the relationship of a 30, 60, 90 triangle. Now, because each of these are a different angle, they're going to have three different side lengths. Across from the 30 is going to be a shortest, across from the 90, well, that's our hypotenuse, it's always going to be the longest, and across from the 60 is going to be our middle length one. Now, we're going to start this out by actually drawing an equilateral triangle, so where they're all the same. This cannot happen as a right triangle. It can only be well, a non-right triangle in order for this because we know a hypotenuse would have to be the longest side. Now, if you watch the earlier videos, we saw for a 45, 45, 90, we talked about how the diagonal lengths were not perfectly equal to 1. This dot paper is actually different. This is known as isometric dot paper. And what that means is that between every two dots is exactly the same length. So each of these, as I drew this is, I guess, would be considered a rhombus. So each of these are the same length. They're just not at a 90-degree angle. So in order to draw a 4 by 4 by 4, so that's what it's asking me to do, triangle here, I'm going to draw out 4 dashes. So 1, 2, 3, 4. I'm going to go down 4 dashes. 1, 2, 3, 4. And I'm going to go across 4 dashes. 1, 2, 3, 4. So I have a 4 by 4 by 4 triangle. Now, once again, we have to figure out what does this mean to be a right triangle. Before we do that, let's talk about the idea that because each of these are the same length, their opposing angle has to also be the same size. So if I take my full 180 degrees and divide it by all three, I get 60. So if I erase this a little bit, currently each of these are 60 degrees. But I still don't have a right triangle. So in order to find a right triangle, we can drop what is known as an altitude from any of our corners, any of our vertices, directly to the other side. An altitude has to meet at a 90-degree angle. So I'm going to start here. I'm going to draw directly down. And because this is on this nice dot paper, I can make sure that I am hitting this at a 90-degree angle. Once again, because this was an equilateral triangle, when I dropped that latitude, or that altitude, sorry, because this side and this side are equal, when I dropped that altitude, it perfectly bisected this angle. What that means is it split it in half. So now this is a 30-degree angle. This is a 30-degree angle. And all of a sudden, I now have this right triangle I was talking about. I have a hypotenuse, I have a side length, and I have the other side length. So I have this, and if we look at the angles, we have a 30, a 60, and a 90. So our 30, 60, 90 triangle is actually built out of a larger equilateral triangle. It's just half of it. And so we can use what we have here to try and find this relationship. The first thing I want to think about, I know that this side here, my hypotenuse is 4. That one we were given to start. But now that I split this other side in half, the whole length isn't 4. But notice I just said it got split in half, and we can actually see it is 1, 2. So this side is 2. So across from my 30, I have a 2. My hypotenuse is exactly double that. It's 4. But we also need to figure out what is this relationship. I'm going to call this h because it's a height. And so we need to figure out what this one is. Notice it is not the hypotenuse. It is one of my legs. So when I decide to come over here and do the Pythagorean theorem, I'm going to do this up here. Notice this down there. This is going to become 2 squared plus h squared equals 4 squared. Once again, in this case, h is representing this height. Even though it's diagonal, it's a height because it dropped from 1 all the way down to the other side, not the hypotenuse. So h squared is equal to 4 squared minus 2 squared. So h is equal to the square root of, well, 4 squared is 16, minus 2 squared is 4. That gives me the square root of 12. Now, I know that that's not a perfect square, so I got to figure out, can I simplify this? Once again, my perfect squares are 1, 2, not 2, 1, 4, 9, and 16. Once I get to 16, I'm too big. I know 9 doesn't go into it, but you know what? 4 does go into 12. So I can say this is equal to the square root of 4 times the square root of 3. This is useful because we know the square root of 4 is 2. So I get h equals 2 root 3. So this right here became 2 root 3. So if I just take my small triangle at this point, I'm going to turn it on its end. We have across from the 30-degree angle is 2. Across from the 90-degree angle is 4. And across from the 60-degree angle, I have 2 root 3. Some things that I'm noticing is 2, 2, and then if I double 2, I get 4. I also see that I have a square root here in one of my side lengths as well. So just like we did the other one, we're going to see if this works again, this time using an 8 by 8 triangle, or 8 by 8 by 8. So you know what, let me go back to using black for the side lengths. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So each of these is currently 8 long. We're going to go through and we're once again going to drop the height. When I do that, it split this side in half. So this now became 4. I have my right triangle here. This got split in half, so this is my 30-degree angle. So this is my 60-degree angle because it was part of my original equilateral. So once again, I'm noticing that across from my 30, I have a short side that's 4. My hypotenuse is perfectly double that. Let's see if we see a similar relationship when we do our height. So for this one, it's going to be 4 squared plus 8 squared equals 8 squared. As I isolate, I get 8 squared equals 8 squared minus 4 squared. So h is equal to the square root of 64 minus 16. That is 48, so h is equal to the square root of 48. Once again, I'm going to list out my perfect square. So 1, 4, 9, 16, 25, 36, 49. So I can go all the way up to the one I have. 49 is obviously too large. 36, if I double that, it's not going to fit. 25 doubled is 50. That's not going to fit. 16 might. So I'm going to do 48 divided by 16. And you know what? That goes in 3 times. So I get h equals the square root of 3 times the square root of 16. This is useful again because I know the square root of 16. So I get 4 root 3. If I come up here and draw this next to my triangle that I had earlier, I'm going to draw the one, once again, I'm taking this one and I'm just going to put it up here. We see that across from my 30 degree was 4, across from my hypotenuse was 8, and across from my 60 was 4 root 3. Once again, I'm noticing that the short leg is 4, the long leg is 4 times root 3, and if I double 4, I get 8. So I'm seeing this same pattern in both of these. Therefore, we can come up with our conjecture or our rule. We can draw a triangle and label it as a 30, 60, 90. Notice I tried to make it actually look like the legs are different. The short leg always goes across from the 30. The longer leg always goes across from the 60, and the hypotenuse always goes across from the 90 degree. For each of these, the relationship started in the legs. If I know what one leg is, then I can find my longer leg. So my short leg across from my 30, we can label x, whatever that is. My longer leg, I take that same value and I multiply it by root 3. Lastly, to get my hypotenuse, whatever that value was, we simply doubled it to get the hypotenuse. So therefore, I can say whatever this value is, simply double it to get the hypotenuse. Once again, if you're actually one of my students watching this, go ahead and take a moment in your notes to write in your own words how you might summarize this relationship.